rank plugin. For this issue specifically, the main purpose is to help me understand LTR, the code, and how it works internally, the code execution flow. And I also just want to share with the community, see if we can have a common, a sense or a common knowledge before we have any discussion on new features or the visions for the next step, how the LTR will move forward. So this first picture is Mark shared that last time. Just want to recap. The red boxes are from the LTR plugin, and the blue ones are actually that we as a external developers need to prepare and contribute. So we use LTR, the learning to run plugin, to get the feature values, and we merge that with some judgment, whether it could be implicit information, and we put it together as a training data set, and then we come up with a model. Yeah, I will come up with some details later on, but the core relationship here is the mapping, which is a grade. The grade is from the judgment, and map to the features. It could be multiple features. We use a concept called feature set in learning to rank plugin, and we need the document identifier to know which document actually related to the grade and the features. And yeah, so I mean, this came up with this sequence diagram. There are several flows. I'm just going through that from top to bottom. We need to initialize the plugin store. That's pretty nature. If we want to store something, the metadata about the feature and the models. Everything is within the open search. So we need to store, if we want to store something, we need to create an index. That's pretty nature. And yeah, the next thing, we need to create a feature set. So I actually want to go to the steps here, just comparing, obviously comparing by looking at the sequence diagram and looking at what exactly the request it looks like. And there are some code digest too. So if we go back to the create index part, it's pretty straightforward. It's just underscore LTR, and the index name is called .ltr store. I think Mark had an issue last time that if you search all the indices directly, you cannot find it. But if you search with a wildcard, you will be able to find this index.
Is that weird? I do see other dot, like the dot Kibana index is in there.
Yeah, the dot is the system index.
Right. I guess maybe there's a distraction, but I can see the dot Kibana index, but I couldn't see the dot LTR store. Still, is there a difference?
Well, then we need to understand how the Kibana index is being created,
right?
And what's the difference here? But that needs more research, I think.
Is this on your own build, or are you talking about running this on AWS?
It's both. It's the same.
Okay.
Using AWS, it's the same.
Yeah. For me, it's just local, running it locally.
Okay.
Yeah. Cool. Yeah. I think for you ask this, there might be some permission inquiries, but yeah, maybe. Yeah. So the next step is create a feature set. The feature set concept, first we need to understand what is feature. A feature is just templated queries. So I call it templated because there are different templates. Besides the familiar ones like the mustache, that's the one we're familiar. So I this example here is actually a perfect one that have multiple template examples. We have mustache, we have this one is called expression, and we also have the script feature. So all of them can be used to track the feature and track the feature values. But the most frequent being used one is the mustache one, because you can put a query there, like and using this like a bracket here, curly bracket here, and put the keywords, and yeah, we will go through like the actual search and talk about how the feature set and the features being used later on. But before that, just want to have a common sense here, like, okay, when we talk about the features, it's actually the query template. Okay, so if we go back to the original sequence diagram, we talk about the first one, we talk about create a new feature. I mean, add additional feature is basically the same thing. No, it's just like if you take a look at this one, like as if we know the feature set name and the features are just a list, so we are just basically append on this list for new features. And then the next one is quite interesting, the search with SLTR filter. I mean, like we call it the SLTR query sometimes, but it's actually just a filter. And if you want to understand better on what exactly it does, so we take a look at this example together. The filters here, like it's just a conjunction. And this term filter, like this one, is just something we want to put on to accelerate. It doesn't really like take into the count, but the most important part is SLTR one. It's a store, it's called store LTR query. Basically, we want to store the values while we do the search. And this underscore name, like that's the key point on how the store is happening, because we are using the name query functionality within OpenSearch. And we basically tag this name to the feature set itself. So that's when the search happening, the match docs gonna be like attached to this specific query. So that's the secret of like how we do the value, like a count of value or count the feature value for each individual query or each individual features. And if you take a look at the parameters, it's basically, it's called keywords Rambo. So like it's basically fit into the mustache template. And the ext part, that's quite interesting, right? Like the log spaces, that's basically how we name it. But the ext is the extension, like the extension feature within OpenSearch that's already exists. And the LTR underscore log, this is a keyword being used for the logging the feature. And the log specs is the name. We can name it whatever we want. And the names here, it's regarding to, okay, like named query, the log feature set, that's mapped to the underscore name here we have. That's how they connected together and then do the replacement later on. So there are basically 3 bullet points I listed here. First, the SLTR is rewritten into a ranker query. The ranker query is also like a data, it was like a query within the LTR plugin itself. And the key point of this ranker query is it actually do multiple things. Like it do the rewritten, it also do the ranker, like it's also do the ranking, and it also do the like a secondary ranker use the ML model. So the SLTR query is happening like everywhere basically. It will be rewritten into ranker query. That's the key point here. And I already mentioned regarding to the name query, like the named query functionality, and this happening under the match query phase. After then, the most important part is like how these actual features is being recorded or being logged. So that's within this ranker query implementation. It has a like an instance of this log consumer, and the log consumer will actually do just append a doc field for each search head. This is happening at this like a fetch. It's during fetch phase. It's called a logging fetch subphase. It's just one of the subphases of the fetch phase. And if we take a look at the code, like and the stack trace, we can pretty straightforward, I think. So first thing is the execute query phase that's happening here for bullet 1 and bullet 2, and then going to the fetch phase. So it's here. And if you take a look at this process, like a process method, what it does is like using the docset iterator to find the docset, like find the doc ID, and then this l.nextDoc, this function is actually do the that's the L thing is a heat log consumer, and it's nextDoc, the nextDoc method is actually do the append of the document field. So yeah, like this advance, I think it's pretty common. Like the advance is from the docset iterator, and yeah, if you take a look at yeah, like the stack trace is from the login subphase, so that's something we already know. And yeah, like the next doc function. So you take a look at the next doc function, it's also like pretty elegant being implemented. It's just like a set doc field. That's what I already mentioned. And yeah, like so yeah, this is just an example of how it looks like. So it's called underscore LTR log. That's a reserved field basically. And then this log entry, that's whatever we want to call. And the the name is actually regarding to the feature, and the value is actually the value of the feature. So yeah, like that's basically how the feature on the SLTR filter works. Like I can pause it here a little bit if we have any questions regarding to the SLTR query, or if I missed anything.
This this makes things a lot clearer, at least for me.
Sounds good. Positive feedback means like at least like for folks who have some like background with OpenSearch, are pretty familiar with OpenSearch, I think you already know how it looks like internals. So yeah, if we already have a common like understanding of the SLTR query, another interesting part, I mean, like the upload model definition part is pretty straightforward. It's just an object, like a model object, and then you attach it to store under this like the metadata or like the system index LTR store. So that's nothing special. And regarding to this, the next part, the search query is a rescoring user model. Like this part is, I think, more closer to the production use case. Like, so I'm not sure if I attach a query here. Yeah, I probably didn't. Like, for this, I can find it out like using some public documentations. Let me find it out. So LTR. Yeah, assume this document is still in public, so we are able to take a look together. Like, so what I want to bring up, like the how the model looks like, and how we really use the model. So like I think last time Mark actually provide some pretty good like steps through how we train the model, and just want to get an output of a model. So different model have different like types of output, but the format should be like based on the documentation. Like they should be like, if the XGBoost model, it should be looks like this, for example, and the linear model should be looked like this. So like there are format of the models, basically. That's what I want to say. And the grid model, like it's just like this, like the request, it just looks like this. Like it's pretty straightforward. And let's go to the search result there, like the rescore one. Okay, so that's the one I want to bring it up. Like if we go back to the sequence diagram here, so we see like a search query with rescoring using the model. Like this statement's pretty, I think it's pretty clear on the like a inference that it's basically a rescore. It's basically a rescore query. and we put the SLTR query here. That's what I said before. The SLTR query will be rewritten into ranker query, and then the ranker query will use, if there is a model field, so the SLTR query or the ranker query will do the secondary ranking based on the model itself. And it's
So is that where, so the SLTR is where the feature logging?
it do everything, actually. It do everything. Yeah.
In this
So
case, it's not. It's just rescoring. It's not.
No, you can do both. Like if you want to put a name field, it will do the logging, and
Right.
if you using if you want to logging it during the rescoring phase, there is another functionality we can use on OpenSearch. It's called something called a ranking index or something, like, and to find the exact name. Like you need to identify that. If you put the SLTR query in the like a rescore phase.
I think I have like two high level questions. One is about the models, and just, I think that my understanding is there's a limit to the size of a model that makes sense to load into OpenSearch, into the search index, right?
Yeah,
and right, these models that we're talking about, they're not going to get any smaller, right? They're just getting bigger, and I'm curious about, that's one question I have, is how to handle that.
It also seems like maybe this is a place where the LTR effort doesn't need to lead. I mean, aren't we already in various environments like ML Commons trying to figure out how to support really large models? And this might be an area where the LTR effort could follow and say, we're going to do what ML Commons does. Because if it works for ML Commons, it should work for us. I don't know. Is that reasonable, or am I missing something?
No, I think that makes sense. I think, right. I think one of the things, Manal, I believe that you're working on is this idea of connectors to external models, right? And that
the reason the LTR stuff today supports models is because when it was built, there was nothing that did models. But if you were to start from scratch today, you would be like, I don't want to support uploading and downloading models. I want to use the universe of options that are coming online.
Right. So a connector to whatever model you want to use, and on whatever platform you're interested in, you can hook up your own API to something that calls that model, or use whatever. So I think that's an interesting point. Go ahead,
Mark. This would be part of remote inference work, which is already out there, right?
It could be, right. I think one of the questions is what is hooking, where in LTR do we hook this up, and there's, again, I think my thinking is there's the concept of learning to rank, and then there's the LTR plugin, and I think that the concept of LTR, my thinking is the concept of LTR is going to way outlive the usefulness of this plugin. Sorry, Eric, and
right? Yeah, no.
But I think that's the idea here, is there's the idea of taking user input and saying, and other data input, and saying, oh, we can dynamically address Lewis's needs in search differently from Andre's needs, depending on what they're, even with the same search query, right? That's learning to rank in general. And then the question I have is do we continue working on this plugin? Is there something already that we can put together that is learning to rank, but adapts like the things we already have. Like why put all this effort into something unless if we're talking about backwards compatibility and being able to help existing users continue. Like why not just say we have learning to rank and it's this other thing and it's different, but it does what you would expect a learning to rank component to do. Because I think that, right, so I think remote inference, yeah, that's something we should think about integrating. Maybe that's a next step. And then the other piece is what we've actually heard some complaints about. I think we've even also asked you, Eric, about this, like logging, like the feature logging, and how you have to rerun, in some off-peak time, rerun your queries. Is it naive to think that something like a message queuing or could help that? And
so you can,
that's basically it, right? Like because what we want to do is log the association between the document and the feature and that query. That's the point of feature logging. So, and we can only do that if we're capturing it at query time.
Exactly. I mean, the challenge with the LTR plugin has always been that the plugin in itself is pretty small potatoes and pretty straightforward, right? But if you only could build the plugin, this is what you get when that's the lever that you can change. If it's the concept of LTR, if you were to do it the way you'd want to do it, it would be tied into a larger approach, right? One that leverages the model support that we have, one that leverages the event tracking and logging, one that leverages the dashboarding, right? And at the end of that implementation, what the plugin is left with is probably something pretty slim that says, and I take this query and I hook it up to a model somewhere, right? Learning to rank, what we need to not take our eye off the ball of is the learning side, right? Because so many people build LTR solutions, but then they never go back and do the learning side of it because that feedback, right? What you just said about, the logging and all that, right? So we need to keep our eye on making sure the learning part is really robust, and whatever the specific implementation for ranking, that'll evolve and change over time and get better.
So like the learning meaning training the model or updating, right?
And updating the model and learning from traffic, right? Because a lot of the features, right? A lot of the features that we want to do are ones that we're learning from user behavior and user traffic, right? That is where you start learning that, hat in the summer is a very different product category than hat in the winter. Unless you're in Florida, where the hat is always the same, right? That's like the insight that we need to learn over time, and that we can learn it from our users instead of a whole outside massive AI, blah, 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 right? That's general purpose. We can learn those insights. And, the hat example is a pretty obvious one, but there's lots of other search use cases where the only source of learning is what our users are doing.
Right. Yeah.
And to tie back to why LTR in a world of LLMs, right, is because maybe the LLMs for our specific business or specific use case doesn't actually know about those insights. But if we can learn from user behavior, we can learn those things.
Right. Yeah. Okay. Andre, there's this, so I know you're focused on core and like a lot of observability type cases. I'm wondering if you have any questions, thoughts about any of this.
Oh, sorry, for TL, I'm more like an observer here. I'm just curious about the feature itself, but unfortunately, I don't know. We don't work with that. I don't work with this feature specifically. I don't have any plans for using it. I'm just curious to understand, like, in general picture, what it is, how it works, where it will fit in the future. But I sadly don't have any practical use of alpha deck at this moment.
Right. You're using, I mean, you're working on observability and analytics.
We do, yeah. I'm
That's
partly in this areas as well, but not like LTR is pretty new for me. I see it's pretty powerful, but I don't have any like hands-on experience with this. And
okay.
Sorry about that.
Okay.
Cool.
Do we have, so I think that it sounds like two areas to investigate would be like remote inference. I mean, maybe it'd be good to add this into the issue, since we're talking about it. We're recording anyway, but that we want to look into the remote inference that Manal was talking about. And
can you say more about what is remote inference? It sounds cool.
It does, doesn't it? I believe she dropped off.
I meant to ask that. I should have asked.
I should have asked him also.
Yeah, like from the naming, it's just like a trade-off between like scalability and the performance or the latency.
Well, yeah, like mostly I think of it in this context as like off-box re-ranking, right? So the kind of thing that you do with a search response processor,
right?
Yeah. So to do like sort of a final stage re-ranker, which has the downside that you're not re-ranking shard results. So that's where, there was some question of like, hey, should we have the ability to re-rank shard level results externally? Because right now we're only doing it on the final result set.
And I guess this also gets to like conceptually, I mean, it's interesting, right? Because we also maybe have, I don't know, maybe I was advocating for the version of LTR where the whole life cycle of the LTR is happening inside of OpenSearch, right? And remote inference is the direction of OpenSearch is super, super thin, doesn't do much, and everything is outside, right? And so, like your learning system, i.e. the training, would all be outside OpenSearch. Feature engineering, all outside of OpenSearch.
But yeah, we're creating, I think it's creating the hooks to make it easier so that you can do that, right? So if we're talking about collecting the user behavior data, you can put that on an object store, you can put that inside OpenSearch, you can put that wherever you need to, whatever makes sense for your scale, right? Like that's part of it. But we don't have those hooks right now. All we have is
this,
right? We have this outside, and then you have to format your data as a judgment list and say here it is LTR, right? And I think that's
like we do have connectivity to external re-rankers. Like really, if you're using AWS Personalize, that's actually very conceptually similar to LTR, right? That you're still but it's being managed through a separate service.
Right. Personalize is doing all of the we're collecting the user behavior, we're ranking, they're doing a lot of things that LTR does on its own. And I think there is an investment, like people are using LTR and want it to be like, we have some issues in that repository now, asking for improvements. And I just, I'm wondering, it feels like we're at a point where we can evolve this or replace it. I don't know which like architect, I think as long as the interface works, then it doesn't really matter. So I think this is definitely one area, right? So this is literally like it's in the documentation. You can connect to Cohere or and this came after that search processor repository with the personalized plugin. This remote inference came after that. So we've had some conversations in this meeting about like, what do we do with that? Do we refactor that thing so that it's connecting to externally hosted models like with this, or do we leave it alone and just move on? But I think it's this, and then right, like figuring out what to do. Go ahead, Eric.
What I'm definitely hearing is that there is not a right answer when it comes to machine learning models. For all the arguments that you want to host them yourself, there's the other argument about external, and it's literally writing, literally right there in the docs, right, that you shared, right? Connecting to externally hosted models, using ML models within OpenSearch, or managing ML models in OpenSearch dashboards. Like, maybe to make LTR really useful, we need to break this link that the model has to be in here. And maybe the direction is to just leverage the ML commons, and hopefully we get the, hey, if it's externally hosted, great, we get it. And if it's internally hosted, we get it. But then that whole area of LTR can go away as unique code that needs to be supported.
Yeah. Yeah, I think that's something we can.
And I mean, maybe down the road, when you use LTR, the plugin, what you're really using is just a bunch of configuration that represents, like, this is the smallest version of LTR, where we use the model that's inside of OpenSearch, and we don't, you have to use judgments, and we don't collect any data or something. But if you change a couple of parameters, now we're leveraging these other things, and the LTR plugin is not, it's just LTR. It's not a plugin anymore. I think that's also what you were saying, Mark. Like, we have to think of LTR not as a plugin to OpenSearch, because it's just too narrowly defined. And we have to think of, like, machine learning. That's not a plugin to OpenSearch, is it? It's a whole thing.
Right. It's a whole, yeah.
And
right.
LTR is a whole thing. It's a whole philosophy around how to improve your search quality by leveraging user behavior and feature engineering and learning and models and tracking all of this data and the feedback loop and deploying new models automatically. That's what we really need to be thinking about. And LTR plugin was just a pointer from a number of years ago.
Right. And now there's been so much evolution in how machine learning can be used, and that you can pull a lot of this out, and probably need to pull a lot of it out, like, because of the scale of these models and how large, and I'm not even talking about the LLMs, I'm just talking in general, right? Like, just models are larger than they used to be. So, okay, cool. So I think, like, I think we want to document some of this. I would like to post, I don't know if we have like 5 minutes left. Does anybody else want to chime in on this topic? So I think we could probably stop recording. I would love to post this